Hello again. We're going to look at section 11.5, common and natural logarithms. And if you have noticed on your calculator, keys for either log and pretty close to it, usually the key below that, it's ln. These are the keys that we use for the common logarithm and the natural logarithm. But that key for the log is not used just for any base. It's very particular. So we're going to look at what common logs are and how to evaluate them. We're going to look at applications of common logs, so that will be part 1 and 2. Then we're going to look at the natural log, that's what that ln is, and look at some applications of natural logs. And then in part 5, we're going to look at what happens if it's not a common log and it's not a natural log. So common logs are actually very specific, and the name comes, of course, from being common, but also because we use a base 10. Our numeration system is decimal, and this log is also of a base 10. So you would normally have something like log base 10 of 23. The calculator can do that directly for you, but actually instead of writing log base 10 of 23, since it's so common, we write just common log of 23, and it is understood that the base is 10. If the base is missing, it's because it's a common log and it's a base of 10. So this would be as simple as pressing the key for the common log and entering the number 41,600. The only other possibility on some calculators is that you put the number first and then you press the key for a log. Now, if you're using a TI-30, I think most of those will do it in this way. And that's a little bit nicer. But if you get an error, it's because you need to reverse that order. So you have common log of 41,600. If it open parentheses, get into the habit of closing the parentheses, and you get an answer of 4.619093, and so on. I didn't specify how many decimal places, so let's leave it at that. Now we do the same thing here, either log of 43.5 or 43.5 and then log. So we do that, and that will give you 1.6384892557. Okay, the same with this one. You have log, common log of 0.442, and that gives you a negative 0.3545777, and so on. And it's as simple as that. Now, it's not absolutely necessary that we check it this way, but think about what this means. Remember, we said that common log of 0.442 means log of base 10 of 0.442, and we found out that it's equal to negative 0.3545777. What this means is that if you take a base of 10 and you raise it to negative 0.3545777, you will get approximately 0.442. And I say approximately because there were other decimal places here and I dropped them or round them, so it will actually be working on that. But the calculator will do that for you directly. Now, one application of common logarithms is actually the pH balance. You probably have heard of pH when you're looking at substance. It's not something that you will use unless you go on and take another science class or maybe a chemistry class. So I will give you what the formula is for the pH, but you are going to need to have a little bit of background information and also know how to use that formula. The pH is a way to measure how acid or alkaline, that will be the opposite of acid, a substance is. I actually want to make that bigger. Maybe not that big. Okay, that's better. So for example, pure water is supposed to be neutral and it has a pH of 7. Acids would have a pH that are less than 7, and the opposite, which are alkaline solutions, will have a pH greater than 7. Now here is the formula for the pH. The pH is equal to the negative common log of that hydronium ion concentration. Now, this is a symbol from chemistry, but it really just represents a particular number. So if you rather call that X and make it easier on yourself, you have pH equals negative common log of X. But X will represent that hydronium ion concentration, and the units for that are moles per liter. Something else is that anytime that you mention a pH is actually written with only one decimal place. So it's rounded to the nearest tenth. Now you have several problems on your homework exercises and in the exercises in general and the examples that refer back to an example in your book on page 704 where it talks about wetlands. I guess it all depends where this particular substance or this particular solution it's taken from. Now, when it's more specific, and this is very specific, it's from ecology, when it's taken from a wetland, according to the pH, it could be classified as a bug, a poor fin, and a rich fin. But it actually depends on the pH value. I don't expect you to know this. I will give you this information if I wanted you to keep going further and classify that as a bug. But notice that it says it will be a bug if the pH is less than or equal to 3. It will be a poor fan if the pH is between 4.0 and 6.0. And it will be a rich fan if the pH is between 6 and 7.5. Here's the actual question. Here is what algebraically or mathematically we're more interested in, which is actually understanding how to use the formula. It says find the pH of water with a hydronium ion concentration of 1.2 times 10 to the negative 3. And right there and then you know that that symbol, that substance, has an H3O of 1.2 times 10 to the negative 3. They also have a second question, which is if it's taken from a wetland, is the wetland a rich fan, a poor fan, and a bug? So that's when you would have to refer to this definition that they give you on page 704. But now, for the formula, you have pH equals negative common log of that hydronium ion concentration. And I'm not that interested in you using that symbol correctly or writing it correctly, just knowing that that's what the hydronium ion concentration is. So we substitute that hydronium ion concentration for the 1.2 times 10 to the negative 3. Substitute that value in the formula for that. Don't think that you have to know how to enter this information into your calculator in scientific notation. You can actually just treat it as 1.2 times 10 to the negative 3 when you do this. And you don't have to necessarily break it down into different steps using the properties of logarithms. You can just enter that in particular as a negative. So the pH will be a negative, so you use that negative symbol from your calculator, then the log of, and then think of 1.2 times 10 raised to the negative 3 in parentheses. Now, if your calculator doesn't do this directly, then what you have to start backwards. You have to take 1.2 times 10 to the negative 3, then take the log, get an answer, and then use that negative symbol. Either way, the pH turns out to be, let me go ahead and do it on my calculator, negative common log of 1.2 times 10 raised to the negative 3, and I get 2.92 or so. Remember, the pH only uses one decimal place, so it would be 2.9, and that is your pH. Now, the classification, we go back to this information we're given here, and it says that it's a bug if the pH is less than or equal to 3.0, and that's what this one will be. Now, we can turn the question around and still use the same formula. pH equals the negative common log of the hydronium ion concentration for that. And when you do that, the question now is find the hydronium ion concentration of a solution with pH of 4.6. Okay, so now you're given that the pH is 4.6, so you're substituting on this part of the equation for 4.6. So notice you have 4.6 equals the negative common log of H3O, the hydronium ion concentration, but you're looking for that. Remember what I said, you can think of this as a variable if you prefer. Think of this as an x, and you want to get to that x. So one way would be to change it into exponential form, but we need to get rid of that negative. So you divide both sides by a negative, and that gives you negative 4.6 equals common log of H3O. Then you're going to go ahead and change it into exponential form. Don't forget that the common log has a base of 10. So you're saying that you have a base of 10 raised to an exponent of negative 4.6, and is equal to the H3O. Then it's just a matter of raising that 10 to a negative 4.6 power in your calculator. So 10 raised to a negative 4.6 will give you that the H3O, and actually my answer is in scientific notation. You have 2.51, and then you have, I have on my calculator E a negative 5. That really means 2.511 times 10 to the negative 5. And don't forget that there are units for the hydronium ion concentration, so that will be moles per liter. Okay, now we are going to look at the natural logs. In the natural logs, we still use a calculator, and for the natural log, we have a base of E. E is an imaginary number that is approximately equal to that. And you may not have seen it before, but it's actually, it's very common in applications of nature, especially those that have to do with growth and decay. So we're going to use that, And so instead of writing log base e of x, we use just ln of x. And that stands for natural log. It almost seems like the L and the N are backwards here, but we still want to keep it as a log, so that's actually a log. Now, we are going to look at some powers of E. So usually when you look at your calculator, you have a key that has the ln, and it's right on the key. Now, that it's called the primary key. Then when you look at, I don't know if I can write with that, the second function on your key, for that same key, you have an e to the x. So that means I'm going to have to use that second key and the natural log to get to the e to the x to do some of these problems. But it's the same key, but I use the second to get to the e to the x, but I just use only the natural log to get the natural log of 91 and the natural log of 154.5. Okay, so let's go directly to those. So I go second, and the natural log key, and it will open something that looks kind of like this. Now I need to enter the 3. That's one way. Another way is you put the 3 first, then you go second and natural log, and you press equal to get that. Either way, when I do that on my calculator, I have e second natural log, and then I have e raised to the third power, and that turns out to be 20.085536 or so, and that is your answer. Now with e raised to the negative 1.2, you have to be careful because it's a little bit tricky. In my calculator, I can go second natural log, then it opens the e to the x, so then I put a negative and then 1.2. However, if your calculator does it a little bit differently, then you will have to do that in a different way, and you will have to change it into, you would have to put the 1.2, then the negative, then the second, and the natural log to get to that. But in either case, your answer will be e raised to the negative 1.2, and your answer is going to be 0.301194. Now, for the natural log, it's just the key that says natural log. The only difference in some calculators is that you may have to put the 91 first and then press the natural log, or the reverse. But in this case, when you take the natural log of 91, you get 4.51085. This one, you take the natural log of 154.5, and that will be 5.0401, and so on. Now, I'm going to stop here for your exercises. So I'm going to give you what exercises you can do already from this section. We're going to stop here so you have time to work on 11.4, and you don't have as much from 11.5. We have in this section we have 11.5. You have 10, 20. You have several exercises here. So for homework, need to do number 10 and 20. Then we have 22, 24. Go ahead and omit 26 completely. But we can do 27 and 36. $39. Yeah, we can do 39. And that's it. Let's just stop there. So I expect you to have questions ready for me on Monday, March 2nd or 3rd, on those, but the section won't be due until we finish this section. So on that Monday of next week, I expect you to turn in 11.3, have questions ready from 11.3 and 11.4 and turn those in, but not this one, but have questions ready.